So what I'm going to be talking about, it's a little bit different talk than I usually give a, fully technical talk. And this is technical, but it's most of it's not my work. So what it is um, excerpts from this book that I'm going to be describing and videos of the investigators and authors of the research in the book, some of them, not all of them. And so you'll see it's a little unusual. I think there's about six or seven of these. So we're going to get very little bits of the research and then some words from the head investigators about their career in computational intelligence. Let me just comment on that title. So I'm a longtime member and activist in the IEEE Society, Computational Intelligence Society. Um, it's strongly related to artificial intelligence, but it's more focused on the algorithmic and data and computational aspects, which is where my research lies also. So that's why the title is Computational Intelligence. So this is about the book series. This is in the book series published by Springer Women in Engineering and Science. I've actually led and edited two of these volumes. The first one was on women in industrial systems engineering. I was asked to do that as a leading woman senior researcher in the field. And it was a labor of love. Let me just tell you, I don't have any financial interest in these books, but I think they're really groundbreaking in the compendium of the technical research, but also that these are women-led investigative teams. And part of the book is the reflection of the women on their career and advice to those that might be thinking of continuing in the career or even beginning the career. There's 26 volumes. You can see the QR code and the link to the series. So this one, after I did the Women in Industrial and Systems Engineering, a couple of years later, I really felt the need for one in computational intelligence. Women are very much a subset of the researchers, but I knew um, probably the majority of women around the world doing research in computational intelligence. And the things they're doing are really diverse and amazing. And I thought the world deserved to have it shared and also to make it something that would be a forever snapshot of this at this point in time. So this was published in fall of 2022. There are 34 authors across 5 continents, 13 countries. Springer's done a really good job on the book. They're extremely high quality. You can get them as both ebooks and as regular books. They're all full color and really beautifully made. It's divided into 4 sections, which is, that was, of course, my choice as the leader and editor: intelligence, learning, modeling, and optimization. There are a total of 19 chapters. Each chapter is a different research investigation by a different team. And that, again, is the link and the QR code directly to the book. There's a couple other books that strongly relate to this in the series: Women in Soft Computing and Design and Applications of Nature-Inspired Optimization. So the first thing I want to show you is the series founder and editor, Dil Chichin, is a woman engineer, but she's made her mark in um, researching and writing about important women in science and technology, mainly in technology. And she's written several books and many articles, and she was the visionary behind this series. So I'd like to share the video with her about describing the series.
I am Jill Tejan, series editor for the Springer Women in Engineering and Science series. The volumes in this series document women's research and achievements across a broad range of engineering and science topics. Its goal is to raise awareness of the pivotal work women are doing of significant importance to our global community. Volume editors select their topic and recruit chapter authors for their volume. The almost 25 volumes published to date range in topic from nanotechnology to sustainable agriculture and food biotechnology, telecommunications to aerospace materials, 3D printing to archaeology, industrial and systems engineering to water quality, renewable energy to computational intelligence. More topics are in process, and I'm always seeking volume editors. Alice Smith is one of those volume editors. In fact, she has now overseen 2 volumes in the series. This volume, Computational Intelligence, highlights women's accomplishments that are setting the stage for the next phase of the information age. I was delighted to write the introductory chapter on Admiral Grace Murray Hopper, as without her invention of the computer compiler and seminal development of the early computer languages, we wouldn't even be in the information age. Thank you, Alice, for your work and your efforts to help make the Springer Women in Engineering and Science series a success.
Okay.
I am Jill.
So she did write this chapter, which is not obviously technical research, but it's a really interesting chapter about Admiral Grace Murray Hopper. If you haven't heard of her, you need to have heard of her. She is a luminary in computing. A personal story is that I actually got to see her long ago when I was a young engineer. I attended a conference where she was a keynote speaker, actually at Society of Women Engineers, and it was really a wonderful opportunity. Of course, she's now passed on, but she's very famous for developing the first computer compiler that translates different language into the binary code. And this is back, she was working on this back in the 40s. These are some photos that are in the chapter, and you can see many of them date from the 1940s, which is why they're not such great quality, of course. And she was instrumental in developing the computer language COBOL. I don't know if any of you still know COBOL. I actually learned COBOL way back when, but thank goodness I never had to do much with it. Was not a big fan, but is well used in business, and as I understand, is still being used in business. The most fun fact that I know about Admiral Hopper is the computer bug, and why we talk about bugs in the computer or the code has a bug or whatever. So there was an actual bug, and this is a photo of the actual bug, a moth. Of course, it was expired, which was in the computer and preventing it from operating properly. And she saved it for posterity in her logbook, thank goodness. And so there it is. It's a photo that's from 1945. Also, she famously carried with her almost 12-inch length of wire because it represented a nanosecond, the distance light travels in a billionth of a second. So it's pretty cool things. So let's get on into the book. These are the chapters in the books. The one in blue are the ones we're going to be looking at, not because they're better or special or anything. I just wanted to pick an assortment of the research that was going on. And I couldn't do them all. It would take 2 to 3 hours to do them all. So there are the other 2 sections, modeling optimization. I'm going to present my own work at the end, which is part of the optimization. I actually have the last chapter, so you will get to see some of that. Okay, so let's just start, and I'm just doing these in order of the way they appear in the book. This is from a group out of France, from the Sorbonne and Université Montpellier. Bernadette's there, the more mature woman, and her former students, Anne and Marie-Jean. And they're working in fuzzy set theory. So the important thing, what they're trying to do is to look at interpretability, accountability, understandability, transparency, etc., in intelligent systems. Um, and they believe that fuzzy models, especially, will be useful in explainable AI or XAI. So they are looking at the human component of the AI systems using fuzzy approaches. So fuzzy logic, if you haven't heard of it, what dates back to the mid-60s by Lotfi Zada, who was also passed on, but was the founder and leading advocate for it, and computing with words. It's a fascinating part of our AI, computational intelligence toolbox, if I can say. And this research team has been working close to 10 years on this particular domain. So several forms of fuzzy reasoning are very close to human reasoning. Um, and these include deductive reasoning, gradual reasoning, analogical reasoning, and inductive learning. And these are some of the ways they can be translated into fuzzy, for example, linguistic decision trees. Again, I'm going through this really quickly. If you're interested, of course, you can look at the book chapters. This is an example. They actually worked with Brazil, of course, a large country in South America, about dengue fever. So dengue fever is a very serious fever. Most people don't die, but some do, and it lasts a long time and is pretty debilitating. And it's spread by mosquitoes, typically in bad water. By bad, I mean standing water situation. So what they were trying to do is learn how, or to investigate how extended linguistic summaries can explain the spatial dimension that impacts phenomena, including this, which of course is a sort of pandemic. So by spatial, we're looking at the geography and the regional aspects. And they're working with public health authorities in Brazil to describe the dengue fever data by natural language, like the higher the temperature, the lower the mobility, the lower the number of cases, for example. And you can see the map they were using in terms of developing their fuzzy linguistic system based on numbers, the data from the cases in Brazil. So let me turn it over to the lead author, Bernadette, to speak about her work in the field.
I am Bernadette Bouchon-Meunier, Director of Research Emeritus of the National Center for Scientific Research at Sorbonne University in Paris. I was the president of the IEEE Computational Intelligence Society in 2020-2021. I have been working on fuzzy and intelligent systems since the 70s. The domain of fuzzy logic and its applications is very attractive because of its capability to handle imperfect knowledge by dealing with uncertainties, inaccuracies, incompleteness, partial truths, and approximation, similarly to what human beings are able to do. Fuzzy systems reason on such knowledge in a way similar to the human reasoning. An interesting property of fuzzy set theory is its synergy with linguistics and cognitive science, which are human-oriented. This is why I have always considered it a very exciting domain. More generally, computational intelligence is based on the complementarity of fuzzy systems, neural networks, and learning systems, evolutionary computation, and adaptation methods, which are at the core of currently trending artificial intelligence realizations. Its collaborations with other domains, such as psychology, ergonomy, cognitive science, biology, linguistics, social sciences, semiotics, make it also oriented towards human agents. Computational intelligence provides key technologies for deep learning, big data analysis, smart X, robotics, and other successful realizations in artificial intelligence, for instance, aerospace sciences, bioinformatics, or business intelligence, to name but a few. To conclude, I think that the most interesting aspect of computational intelligence is its position at the crossroads of several domains and its multidisciplinarity, its human-oriented approach, and obviously the wide range of real-world applications at the service of humanity.
Okay, so that was pretty interesting. Of course, the background is fabulous there with Paris. So we move on next to another chapter. This is by Keely Crockett, who's in the UK. And here she's also looking at the human aspect and including looking at adaptive psychological profiling from nonverbal behavior. And she's working a lot in trustworthy AI systems, which is a really hot topic right now. So, what is physiological profiling? So, what it is a detailed analysis of nonverbal behavior in an interview situation to detect their mental state. So basically, you're filming someone, trying to looking at their eye movements, their hand movements, their all of their stuff, nonverbal, could be even heart rate and so on. And it's a complicated thing because everyone's different and expresses their way different lead. So she's done a number of work in this. In this case, the work that I'm showing here are two systems that were developed called Fathom and Compass. So Fathom is looking at the verbal interview and a learning task. And Encompass, it's visual engagement from an online tutoring system. And so in both cases, they're trying to develop models, in this case, neural network hierarchies or deep learning, to automatically detect comprehension levels. So they're trying to look at not verbals, but nonverbal things to look at how well these students are learning through these systems. Okay, so this is the way that they did some of their studies that were reported. There's the participant, the interviewer, the video technician. They used all women in this study. You can see their ages and 80. So they were able to develop their neural network, had very good classification, although certainly not 100%, of being able to classify students based their learning achievement, not based on testing, not based on quizzing, but based on their nonverbal behavior. So this shows some of the data. This is a time series, both of them on the right, for Compass, for both an incorrect and a correct answer. So you can see that and of course they all are over time. You can see the seconds. They're both complicated, so we're looking at the comprehension being the blue part, and the classification, which is 0, 1, being the red part. for looking at correct answers and versus incorrect. So, and it's a scoring system that they've developed through this classification. And again, it's achieved close to 80% accuracy. So let me turn it over to her to speak about her work.
A professor of computational intelligence, speaking to you from the wonderful snowy Yorkshire Dales in the United Kingdom. I was very passionate about computer science and control technology from a very early age, studying both subjects in school, where I got to dabble in electronics, programming using BBC Basic, if any of you can actually remember. And I loved the fact that it was all about problem solving, but also developing solutions that might one day impact on people. So having studied 2 degrees in software engineering and computer science, I then went on to do a PhD in fuzzy systems. So this was my first real taste of understanding what artificial intelligence, what computer intelligence actually was. And the work I did for my PhD, sponsored by industry, allowed me to delve into other computational intelligence techniques, such as genetic algorithms, ant colony optimization, and immune systems. Moving on to this, I started to work in adaptive psychological profiling, which uses lots of different types of neural networks. And this was way before deep learning was ever fashionable. So today, what do I do? Well, I am an academic, but I spend quite a large portion of my time in industry, doing lots of exciting research projects. And at the heart of everything is people. I now look at AI and computational intelligence as something that can help better people's lives, help humanity, but only if we actually develop it in an ethical, trustworthy and responsible way. So at the heart of it, for me, STEM is about developing solutions that can help people, but also making sure that we take everybody with us on that particular journey. So what I want to do is empower all people to have the same choices and opportunities. And at the end of the day, make a difference. And I'm very grateful for the position and the people I know and the friends I've made on my journey. Thank you.
All right, some lovely words for her. Pretty exciting stuff. The next one is also using fuzzy logic, fuzzy multi-layer perceptrons, which is a form of neural network or deep learning for fuzzy vector regression. This is a group out of Thailand. And you can see we actually did have a few male authors here. So we weren't like totally discriminatory or anything like that. I'm not going to try to pronounce their names because I think I would do a terrible job. I'll let you read them, but this is the group out of Chiang Mai University, which is in the north of Thailand. So this work is highly mathematical, so I can only like give you a little taste of it. Obviously, the chapter includes the full work, but you can see the neural network there, and what they're doing is they're inputting fuzzy vectors and calculating outputs using that. And you can see the graph on the lower left gives you an idea of the fuzzy part, where you've got the membership function over some ranges, in this case, two-dimensional Q1 and Q3, and so on. They use something called cuckoo search. It's a form of meta-heuristic inspired by the bird, the cuckoo, and I know I hate the name of it, but apparently it is quite an effective search technique. I personally have never used it to find the best weights for the neural network. And again, using all fuzzy numbers to in their mathematical approach. So they also did some applications. This one is the one I picked, which is in the Ping River, which is in Thailand, and it tends to flood Chiang Mai. You can see down here, I'm putting my cursor on it. I hope you can see it. This is Chiang Mai, and this is the river system with the different gauges and dams and so on. It's a whole water system. And what they're trying to do is to improve the prediction of when this particular water system will flood Chiang Mai, which is a major city, and it's downstream of all this stuff up above it. Based on readings, of course, upstream, which are obviously a number of hours out from Chiang Mai as the flood might progress downwards. So this is some of the data they were able to use, the different features they could use. These features are both located in certain places along the river and at certain time periods. For example, current time versus um, previous time and so on. And they found they were able to do it really well. This is some of their results showing that they could actually predict it quite nicely in order to help the planners in the city tell people when they needed to evacuate and get ready for a flood event. So let me talk to the let me have the lead researcher, Sani, talk about her life and work.
Hi everyone. The reason that I'm working in the computational intelligence field is because when I was very young, I would like to build a robot who can pray and talk with me. So that's why I'm interested in building a smart intelligence system. And when I went for my master and my PhD degree in US, I met several great professors, including Professor Jim Keller, Professor Paul Gader, Professor Raghu Krishnapuram, who inspired me into working into this field. And when I got back into Thailand, I and my colleague, which is my husband, Professor Nipon Chirayampon, we are working in the same field and we groom a student to become a good researcher into CI field. And we hope that one day we might help the society or we might build a smart system that can help us society. And I also believe in the wording that the character in the field of view movie saying that if we build it, they will come. And also another wording from Forrest Gump, the main character, he's saying that life is like a box of chocolate. You never know what you're gonna get. So I still keep working on this field because I believe that I might end up building some smart system that can help. And also during my working year, I also met several professors from all our work who are interested in the same in the CI field, who making great work, doing on great research. So this is why I'm still in this field, and I hope this might inspiring you into the into working into the CI field. Thank you very much.
Right. That was kind of fun, wanting to be a robot. Um, this is work out of the US from North Dakota State University and looking at deep neural networks versus super learning. This is by Simone Ludwig. Again, it's pretty technical stuff, so I can only give you for a really brief flavor, but what she's working on developing is a super learner by having different candidate learners and then combining them together using a composite model. And she was looking at cybersecurity data. So this test was done on some data generated out of the Canadian Cyber Institute for Cyber and Security, and it's imbalance, which means you can see the number of instances is highly different for the different types of security incidents, botnet, brute force, port scan, and web attacks, and the different features. So she looked at different network architectures. Again, these are neural networks with different classifiers. This is the web attack data. And her super learner was by overall the best. You can see that's in the column second from the right. And it did really, really well, although a lot of the other approaches also did quite well. I'm gonna have her talk now.
Hello everyone, my name is Simone Ludwig and I'm a professor and also the chair of the computer science department here at North Dakota State University. I did my PhD in the AI field of semantic reasoning with ontologies, but I got interested in the field of computational intelligence during my postdoc years, where I applied genetic algorithms to a particular optimization problem. I've been ever since captivated by the computational intelligence field. I've been doing research in all four subcategories of computational intelligence. They are kind of working with particle swarm optimization, genetic programming, ant colony optimization, UNFIS, LSTM, CNN, autoencoder, and kind of many more as well. Primarily focusing on kind of applying these algorithms into different kind of optimization problems, and application areas kind of include, kind of just to name a few, image processing, privacy and security, speech recognition, kind of web service area, as well data mining, including big data processing, and so on. I have been very much enjoying the research in this area, and I love to meet and also discuss different research problems with fellow researchers. And especially, I really love kind of this getting together at a conference where there is this great exchange about different ideas. You can learn from different people, and then kind of also find different ideas that you can then take back to your lab in order to work on these. So yeah, I'm really enjoying working in this area of computational intelligence. Thank you. Hello everyone.
So North Dakota State is the land grant like Auburn is for Alabama. So this work is about lifelong learning machines, developing optimization systems that continually learn. This is out of Scotland. The researcher is Emma Hart here. And so she's focusing in this work on adaptive systems that continually learn and update themselves, so automatically improve when something happens that is not expected or different from what the learning system already knows. So you can see the overview here, different instances, different algorithms, generating them and then tuning them. So there's an exploration aspect and then an adaptation. And then there's this group or so-called portfolio of the superior algorithms is strengthened and maintained, whereas the less effective algorithms currently, the ones that are not learning as the system that is changing, are forgotten or done away with. So, you know, it's very much how human learning might occur, where new things come in, our brain adapts to new situation, figures out new things. I don't know if we necessarily forget all the other ones, the old ones, but they certainly recess in our memory. So here's some words from Emma.
Hi, I'm Emma Hart. I'm a professor in artificial intelligence at Edinburgh Napier University in Scotland. I first got interested in computing back in the mid-80s when I was a teenager, when the original home PCs were first introduced to the market. I learned to write simple programs by myself, sharing my knowledge with my teenage male peers. I was definitely a lone female at the time. Computing wasn't really part of the school curriculum then, and I went on to university to study chemistry. Computing wasn't part of this degree at the time, but in my final year, I managed to do a dissertation with a professor who was interested in exploring computing to model solubility of gases. I wrote programs that were sent off to a mainframe to compile. They would come back several hours later, normally just saying they had an error in them. However, my fascination with the subject grew, and at the suggestion of a friend, I went on to Edinburgh University to study an MSc in Artificial Intelligence. This turned out to be a fantastic course, introducing a broad range of topics in AI. And after the first lecture in evolutionary computation, I knew I'd found my thing. I completed my master's in the area and then a PhD, where by chance I came across the subject of artificial immune systems, which eventually became the focus of my actual PhD. Much of this inspiration for my PhD came from the work of Professor Stephanie Forrest in the USA. She was really a pioneering female in computational intelligence at the time, and I still keep in touch with her to this day. But I've also had the support of many great male mentors in the field along the way, who've supported me and encouraged me throughout, as well as the unwavering support of my husband and children, which really helps. I'm delighted to have been able to push some boundaries during the course of my career, for example, becoming the first female editor of Evolutionary Computation Journal and one of the early members of the Women at Gecko workshops at the ACM Gecko conference. The worldwide community in evolutionary computation is incredibly welcoming. I've made really lifelong friends of every gender and from many nationalities, and I'm really lucky that evolutionary computation has so many female role models. So I strongly encourage you, have a look, find out for yourself.
Okay, very nice. This works out of Singapore. Again, there's a lead woman who's Dipti here on the right, and her male student, Kumar, worked on this. And this is about energy management and control in smart grid using distributed machine learning. Again, this work's highly technical. I don't understand a lot of it because I don't know too much about electrical grid management. But what they're doing is using a particle swarm optimization algorithm. So particle swarm is part of swarm intelligence. It's loosely can be classified under the evolutionary computation domain. I've used swarm intelligence too, and I find it a very effective and interesting algorithm, and it's actually one of my favorites. And they're obviously applying it to the power grid here, very complicated, looking at the control. So in this case, we're looking at smart grids, so it's dynamic optimization, looking at when things should be turned on and off to generate electricity in the most efficient way. And there's a lot of, like I said, technology here. I cannot do this justice, but with looking at different batteries, life, and so on in control systems. And they're using consensus-based. So this is a distributed PSO, and consensus means that you're looking at how the different models agree or disagree with each other. So they studied several different systems. This one is kind of a test system from the IEEE. It's 119 nodes. This is some of their results. And the long and short of it is that their algorithm really does a great job. It outperforms other approaches, maintaining less power loss and managing the node voltages. And the average error is only a little over 2%. And it's as an error that is as low as with the centralized control system, but this is with distributed control. So the system is much more complicated, but it's still able to do just as well at the job. So this is from Dipti. Again, she's at National University of Singapore.
Hello, everyone. I'm excited to take a trip down memory lane to share with you why I embarked on this incredible journey into the field of computational intelligence over 3 decades ago. It all began during my PhD research, where I delved into the fascinating realm of AI applications in power and energy systems. Back then, the field was burgeoning, and the promise of AI's potential was truly captivating. I distinctly remember taking some pivotal courses in AI that opened my eyes to the vast possibilities this field offered. It was a revelation. The ability of machines to learn, adapt, and make decisions was revolutionary, especially in the complex domain of power and transportation systems. The synergy of AI and power systems ignited a passion within me, pushing the boundaries of what was then considered possible. My journey has been filled with countless challenges, breakthroughs, and the joy of witnessing AI's transformating impact on the industry. As I reflect on these 30 years, I'm immensely grateful for the opportunities and growth that this field has provided. For those considering a career in computational intelligence, my advice is to embrace curiosity, stay hungry for knowledge, and never underestimate the power of perseverance. The field is ever evolving, and your contributions can shape its future. Take risks, explore new avenues, and most importantly, enjoy the journey. Thank you for joining me on this nostalgic journey, and here's to the exciting adventures that lie ahead in the field of computational intelligence.
Okay, I really
Hello.
like her words, especially about taking risk and embracing the learning and the journey. So my final part of the talk is my work that I did with Grace Sau. Grace was a visiting scholar with me. She comes out of computer science at the South Central University for nationalities in China, and I believe it's in Wuhan, China. And this is a little bit different work, different for me. She came with this idea of this BAT algorithm, which I had not worked with before, but looking at trying to improve it. A BAT algorithm, again, is part of the swarm intelligence for optimization, in this case, for continuous optimization. So the BAT algorithm uses a group of VATs. They're actually called clouds of VATs. It's the technical term. And so the cloud of BATs are guided using this best BAT to find the best solutions through this continual space in multi-dimensions. We're showing, in this case, just 2 dimensions, but of course, we're going to be dealing in high-dimensional space. So it's a simple idea, which is rather than take the best BAT overall, we take the best BAT in each dimension and then develop a composite learning based on that. So we tested this on a pretty famous test suite of continuous optimization functions. It's the IEEE CEC 2017. CEC is the Congress on Evolutionary Computation. There are 29 functions. We admitted 1. Each of them have 30 dimensions, so 30 dimensions is a lot. We used a cloud of 40 BATs and to look at the variability to see these are replicated 30 times. You can see here how our BAT algorithm behaved compared to the regular BAT algorithm, and we were able to improve on the regular BAT algorithm in 23 times, although we did worse in 6 times. And this is the CPU seconds, and you can see that it's also a very quick algorithm. So we also looked at compared with some other swarm algorithms. These are listed here, and the results were that it did a lot better, not all the time. In other words, sometimes it did worse, but overall it improved on it. And our p-values, which is a measure of statistical significance, showed always that our results were significantly better. When we look at a couple different versions of the algorithm, which is looking at how we look at the ordering of these dimensions, it turns out that it doesn't really matter. So we looked at reverse order and random order, And as you can see, there was no significant change in the behavior of the algorithm. So I'm not going to show you a video of myself. That would be scary. But I'll talk a little bit about what I would talk about if it were a video. So I got my dissertation, PhD dissertation, 1991. So it's been a little over 30 years. I studied neural networks for quality process control. And back then, this was kind of a almost revolutionary topic. It was certainly not really used. So what I was taking is the work of neural networks, which we didn't call it deep learning back then, neural networks coming out of computer science and electrical engineering and applying them to traditional fields in industrial and systems engineering. And I actually was one of the first, not the first, but one of the first to do that. After I graduated, I also got involved with evolutionary computation optimization. So my PhD work was all involved in modeling, and I really wanted to also look at optimization. Right now, I do both. And I had early involvement. This is where I got involved with the Computational Intelligence Society, CIS. I did a little bit in fuzzy logic. I met Loftyzadeh at a couple conferences in the late 1990s. He was very encouraging and welcoming, but I don't really do too much. I've published a few papers in there, but I do a little dabbling if it looks like it would be a good part of what I'm trying to develop. I've taught courses in all these fields. And as I said, I've been involved with the IEEE CIS since 1998. I really like the worldwide effect. As you can see, the people in the book and that we've heard from, which is just a subset of them, are located all over the world. They're doing a lot of technically diverse things as well. And I think it's wonderfully invigorating to be in a field like that. And I've been proud to try to work on advancing this to underrepresented groups, particularly by gender and geography or background. A couple pictures from earlier in my career. At the top, I was looking at developing actually a neural / fuzzy system to improve the manufacture of, yes, toilets. And it's not just work on the computer or in the lab. We actually worked in the plant to learn the process and develop some testing of our different recommendations. Down at the bottom are me with some of my students. Some of them are University of Pittsburgh graduates, where I was before Auburn, but most of them are Auburn grads. I'm really proud that most of my students have gone on to academia and have had their own students. And in general, just like my advisor introduced me into AI or computational intelligence, I've been the one who have done the same with my students. So summary, these are some photos of some of the authors of the other chapters that we couldn't have time to cover because I'm use all my time with what I've got. It's a really exciting field. You can come at it from almost any approach. It does seem to be a very welcoming field. You've heard that throughout the videos. Women are definitely becoming a greater force in the field. There's more people involved, more women people, and especially younger women, which is going to keep our field vibrant and expand the diversity. And so, but it's still important to inspire and nurture everybody to choose this field, but particularly those in women are our target audience. So I'm really glad to be part of the AU AI initiative. I've worked in this field a long, long time, and it's great to see it being developed and recognized for the outstanding technical opportunities and promise that it's got. Thank you all.